This is question 2. In how many ways can 5 beads chosen from 9 different beads be arranged in a row? It's important here to note that the beads are different and therefore distinct. If the beads were all identical, we could just, let's say I had 9 white beads, how many ways can I choose 5 beads? Well, I could get 5 white beads, that would be it. But because the beads are different, I now have to choose 5 of them, and there are different ways of doing that. Let's say I want to arrange them in a row. 1, 2, 3, 4, 5. How many choices do I have for the first bead? I would have 9 choices. I would have 8 choices for the second bead, 7 for the third, 6 for the fourth, and 5 for the final one. I can therefore just multiply these together to find my answer, which is 15,120. Now, you can do this question another way. This question is basically asking you how many permutations are there of 5 objects chosen from 9 objects. 9 permutes 5. And this can be worked out by taking 9 factorial divided by 9 minus 5 factorial. This is in general true, and this will give us our answer of 15,120. What about if instead of arranging them in a row, I wanted the beads to be arranged in a circle? Well, let's first of all choose the 5 beads that I want to arrange in a circle. This means from the 9 beads, I'm going to choose 5 of them. Then I'm going to arrange them in a circle. How many ways can I arrange them in a circle? Well, in general, if you're arranging n objects in a circle, there are n minus 1 factorial ways of doing that. So same thing here, there are 5 factorial ways of arranging those beads in a straight line. However, because it's in a circle, I have to divide through by 5. And this gives me 3,024. You may be wondering why I divide through by 5. It's because for each circular permutation, there are 5 that look identical to it. So let's consider this permutation where I had bead A, B, C, D, and E. This looks perfectly reasonable, but if you imagine them on a bracelet involving E, A, B, C, D would look identical. Just because you've rotated your bracelet on your wrist doesn't mean you've got a new bracelet or that you've rearranged it in any way. It's still the same bracelet. Similarly, I could have D, E, A, B, C, or I could have C, D, E, A, B, or I could have B, C, D, E, A. Because for every arrangement there are 5 identical arrangements, I need to divide through by 5. And this is why we get our formula for circular permutations. So if I want to permute n distinct objects in a circle, the number of ways that I can do that is n factorial, which is, so permutations of n distinct objects in a circle. This will be n factorial ways of arranging them in a line, divide through by n ways of rotating it, which look identical to the original way. So in other words, we can also write this as n minus 1 factorial. Either way is fine, and this is a well-known result.